Hello everyone, welcome to Mechanics of Fluids. Uh, in this video, I would like to discuss about flow measurements. So, what are the quantities we can measure whenever the flow of the liquid is taking place through any pipe? So, what are the quantities? Basically, first we have to know that we can measure for a particular liquid when it is flowing through a pipe. So, assume whenever the liquid is flowing through a pipe, the quantities we can measure. The first thing is the pressure we can measure for the flow of the liquid, okay, and the second one is the quantity we can measure is the velocity of flow, okay, and the third quantity we can measure that is the discharge, with how much discharge it is flowing means how much the volume it is flowing per unit time. So these are the three quantities are related to flow measurements, okay. So whenever the liquid is flowing through a pipe, so these are the quantities we can consider as a flow measurement. So we have to know how to find out these quantities for the flow of a liquid through any pipe or channel. So first in this video I would like to discuss about how to find out the velocity for a given flow of the liquid through any particular pipe. So what is the instrument is available? So by using that instrument, how can we find out the velocity? We have to know. So that is only I'm going to explain now. So the velocity, how to find out the velocity means, here for finding the velocity there is a particular instrument which is known as a pitot tube, okay. So pitot tube is used for finding the velocity at any point in a flow field in a pipe. So again here one more thing I want to tell you. So these flow measurements, whatever the instruments we are discussing in this, so these instruments are related to the applications of Bernoulli's theorem. So whenever we need to discuss about the applications of Bernoulli's theorem, so in that we can discuss about the pitot tube and the venturi meter and orifice meter. The pitot tube is used for finding the velocity at any point in a flow field in a pipe, and venturi and orifice meter both are used for finding the discharge only. Okay, while discussing them, what are the exact difference? What is the exact difference between venturi and orifice meter? We'll discuss later. So now I would like to tell you pitot tube. So here first we have to know on which principle the pitot tube will be working. The principle on which the pitot tube is working means here it depends upon the conversion. Okay, the conversion of total kinetic energy, conversion of kinetic energy into pressure energy. So the total kinetic energy will be converted into pressure energy. So when it is entering into a pitot tube, okay now. So at the entrance of the pitot tube, the total kinetic energy of the liquid or water is converted into pressure energy. So by the conversion of this, we'll be getting the velocity by using the pitot tube. So how we'll be getting means, we need to analyze the energies by using the energy equation, which is the Bernoulli's equation again. So what is the pitot tube means? It is a simple glass tube which is in a shape of L. So that means if it consists of two legs, those two legs are perpendicular to each other, right angle to each other, okay now. So this simple glass tube is connected in a pipe in which we want to find out the velocity, okay. So like this, in a pipe, assume this is a pipe, so in which we need to find out the velocity, okay. So for this pipe to find the velocity, we need to insert the pitot tube like this, and here assume the water is coming with a velocity v. So that means it is having certain kinetic velocity. So when it enters into the pitot tube, at the entrance of the pitot tube, the total kinetic energy will be converted into pressure energy. So the velocity becomes equal to 0. So due to the conversion of this kinetic energy into pressure energy, the rise of the water takes place in the glass tube, okay, like this, into the glass tube above the pipe, okay now. So assume this rise in a glass tube as a small h, okay, and already with how much it is inserted into the pipe, assume it as a capital H, okay. And again I want to consider two sections, so which is at a point away from the pitot tube, and the second section is which is exactly at the entrance of the pitot tube. So this point I want to assume the section 2, and section 1 as at a distance away from the pitot tube. So for these two sections, I want to apply the Bernoulli's equation, for which assume the P1 is the pressure at section 1 and P2 is the pressure at section 2, which is at the entrance of the pitot tube, and V1 is the velocity at section 1 and V2 is the velocity, which will be 0 here. So assume V2 is the velocity at section 2. So now apply Bernoulli's equation. Okay, now so when you apply Bernoulli's equation, apply Bernoulli's equation. So when we apply this Bernoulli's equation, what will be the equation form? The equation already we know, P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Okay, so based upon the horizontal pipe, if you select any reference line, the height will be equal to two sections. So automatically here we can write it as Z1 can be equal to Z2. Okay, due to horizontal pipe, we can write it as Z1 can be equal to Z2. So automatically here Z1 Z2 will be getting cancelled. Okay, so now we can write it as P1 by rho g plus V1 square by 2g is equal to P2 by rho g, and again here according to the analysis, that means by the conversion of kinetic energy into pressure energy, the velocity is also 0, so the V2 is also 0, so total V2 square by 2g term will becomes equal to 0. Okay, so now I want to write it as V1 square by 2g. V1 square by 2g can be written as P2 by rho g plus P1 by rho g. So what do you mean by P2 by rho g, P1 by rho g means these are the two pressure heads available at section 2 and section 1. So here what is the pressure head available at section 1, which is placed exactly at the center of the pipe, means at a height of h from the surface of the pipe. We are considering the center line. At that place only we have adjusted the pitot tube. So at this point, what is the pressure head value means equal to the height only. So this P1 by rho g. So this P1 by rho g is the pressure head at section 1, which will be automatically equal to H. According to the height value, the pressure value will be taking place. So the pressure head value will be equal to capital H. And similarly, what is the pressure head at section 2? At section 2 means according to the height has risen into the pitot tube, that height will represent the pressure head at section 2, which is at the entrance of the pitot tube. So what is the height has risen in the pitot tube means, which is the sum of small h and capital H. So H plus H will be the pressure head at section 2. So this equation again, the pressure head at section 2 can be written as small h plus capital H. So here here we will be getting P2 by rho g minus P1 by rho g. So make the correction. So again here also minus we need to represent. Okay, sorry for that. I want to erase it. Okay, here we will be getting negative sign, and here also we will be getting negative sign. Okay, so now I want to represent here negative sign, P2 by rho g minus P1 by rho g, H plus H minus capital H. So this capital H will be getting cancelled, so it should be equal to small h. So again V2 square is equal to, or V1 square, that is the V only, not V2, V1 square is equal to 2GH, we can write it as. And finally how can we write the V1 is equal to, we can write it as square root of 2GH. So V1 is automatically V, so we can write it as V is equal to root 2GH, which will give you the theoretical velocity. Okay, which will be theoretical velocity. So for writing actual velocity, we need to take the help of CV. Okay, which is the velocity constant, coefficient of velocity, which is equal to ratio of actual velocity to theoretical velocity. Okay, the ratio of actual to theoretical velocity is the definition for coefficient of velocity. So again, the actual velocity we can write it as actual velocity actual velocity is equal to, we can write it as CV into theoretical velocity. Theoretical velocity. Okay, finally, actual velocity V is equal to, we can write it as V actual is equal to, we can write it as CV into, what is the theoretical velocity? Theoretical velocity is square root of 2gh. Okay, so this is the final equation for finding the actual velocity by considering the losses. Okay, so like this we can derive the equation for the velocity, so which will be derived with reference to the Pitot tube, and which is used for finding the velocity of flow only. So I hope you understand. If you still have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video. Thank you all.